Okay, I'm in section 8.1. Number 6, determine the domain of a rational function. So the domain of a function is a set, which means it could be a lot of numbers, a set of numbers that will actually make the problem work. So if you just have a regular an expression, so if you have this expression, say, oops, that's not what I wanted. Alright, so if you have this expression, say 7 plus x equals. And you look at that and you go, wow, any value for x will make this work. If x is negative, if it's negative 5, this would be 7 plus a negative 5, that'd be 2. If x was 0, 7 plus 7 would be 0. If it was 20, this would be 7 plus 20, 27. No problems. I can't think of a number for x that would make this problem such that we could not do it. So the domain of this, so the domain of 7 plus x is all real numbers. Not very exciting. What about a problem like this? F of x equals x minus 9 over x plus 5. Now let's go back to the definition that I have here from page 462. Domain of a rational function, which is what we have. We now have a rational function. Rational function is just a fancy way of saying fraction. Consists of all real numbers, so there's more than likely going to be a lot of numbers, except the value of the variable that makes the denominator 0. So, what we need to do is A, identify value that makes the denominator equal to 0. And then once we do that, then list all the numbers excluding those found in A. So when is x plus 5 equal to 0? Okay, basically when x equals negative 5. Part A is done. Identify value that makes the denominator equal to 0. Well, that would be negative 5. So B, list all numbers that exclude those found in A. Well, we'll just write that as the domain of f of x. And I'm not going to sit here and write out all the numbers, because there's a lot of them. But it's all the little numbers, negative infinity, up to, but not including negative 5. That's the union sign. And then all the numbers greater than negative 5 to all the big numbers, positive infinity. That there is the domain. I got a little bit of room. I'm going to show you one more problem here. Let's take I got a little bit of room right here. And I want to show you this problem. What if I had g of k equals 8 over k squared minus 8k plus 12. So this equals 8 over k minus 6, k k minus 2. Whenever you do these, just double check them. K times k is k squared. This will be a negative 2k, negative 6k, gives me a negative 8k, negative 6, negative 2, positive 12. So in this case, the denominator is 0 when k is 6. 6 minus 6 is 0. 0 times the number is 0. It's also, denominator is also 0 when k is 2. 2 minus 2 is 0, and so forth. So in this case, the domain of g of k is the little numbers up to, oops, little numbers up to 2 union 2 to 6 union 6 to infinity. There you go.